In this video, I want to talk about some thoughts you will have if you think a longer time about the topic, maybe before the exam. Then it comes maybe only for me, but maybe also for you. Then you have some ideas and you think, is that really possible? And one of these thoughts I want to discuss with you here in that video. So I want to imitate a dialogue between me and one of you. Okay, so my name is Joachim and your name is, I don't know, let's say in Germany a typical name is Hans. Okay, and now I tell Hans the following. Please, dear Hans, choose a polynomial of degree 3. Degree 3 here for my example, we can do the whole thing for degree 4 or 5 or 6. But let's say for this example, degree 3. Please choose one and don't tell me. So Hans maybe chooses. And you can exchange this polynomial by whatever you want. Okay. Now Hans has chosen this polynomial, but I don't know. He doesn't tell me which one he has chosen. Okay, dear Hans, choose an interval, but this time tell me this interval. Maybe Hans is choosing the interval 2, 5. And now I tell Hans, take your polynomial, take that integration interval and calculate the value. Okay, so he has a lot to do. And how is he doing? He calculates the antiderivative, a half, and then x to the 4. So we get this antiderivative. Now we need the value for 5 and we need the value for 2 of that. And then we subtract that and then we get the answer. So, and what are these values? Use electronic help if you want to. And in the end we get 41.625. This is the answer. Find the integral value, but don't tell me. Hans now knows the answer is 41.625, but I don't know. So now I do the following. Now I'm asking Hans, give me the value for 2. So here, not for the antiderivative, but for the polynomial, what is the value if you have the input x is 2? So we have 8 divided by 2. 4 minus 8 is minus 4, plus 10 is plus 6, minus 3, this is a 3. So I get that value. Then 327 halved is 13.5, minus 18 plus 15 minus 3, and you get the value 7.5. 464 half 32 and so on, and you get 17. And 5 you get 34.5. And now, knowing these values, I don't know the polynomial. I only know if input is 2, output is 3. If input is 3, output is 7.5. If input is 4, output is 17. If input is 5, output is 34.5. Then I tell Hans I know this number. And how do? I use the Newton-Cotes formulas for degree 3. In this situation, the positions for the standard interval is 0, a third, 2/3, and 1. And then for the interval 2, 5, this gives us 2, 3, 4, 5. And the weights out of the table we know is 1, 3, 3, 1 divided by 8. And so we get 5 minus 2, length of the integration interval, times first weight times first function value, plus second weight times second function value, plus third weight times third function value, plus 1 divided by 8, fourth weight times fourth function value. And maybe by using electronic help, I can easily get the answer 41.625. And so I tell Hans, your integral value is 41.625. Okay, what might be the reaction of Hans? Maybe he's very surprised because he didn't tell me the polynomial, and so I was not able to perform these algebraic doings here. So maybe Hans is very surprised. But thinking a little about the situation, maybe he says, no, I'm not really surprised because if I have these four values for these four input arguments, then it's possible to calculate the interpolating polynomial of degree 3, and then I will get a half times x cubed minus 2 times x squared and so on. And then I can do that calculation. Okay, so thinking about the situation, he says, okay, it's not really hard. But what is my answer? I tell him, no, this was not the way I did the job. I could have done so, but I did not do so. But my way was much easier. It would have been a lot of work to do it that way. So I did it by applying very easy formulas. And maybe Hans, you noticed how fast I produced this value. So this would have taken me a lot more time. So I'm sure that you are still surprised. Okay, new match, choose again a new polynomial of degree 3. So maybe Hans will choose this polynomial. Then I tell him choose an interval and tell me. And maybe this time he chooses the interval and he tells me that interval. So again, please find the integral value. And he will do. And then we need the value at position 4 of that. And doing so, you get this answer. And now the value for -1 of that. And this will give. And subtracting these two numbers, you get this number. This is the rounded version. Yeah, it's not exactly the answer. Now Hans expects that I'm asking for 4 values, but this time I ask him only for 2 values. Maybe it makes sense to have a look into my script. We are here. I want to apply the Gauss formulas for n is 2, and I know if n is 2, then for all polynomials of degree 2 times 2 minus 1, so all polynomials of degree 3, I can be exact. And now we have these 2 positions and these 2 weights. And now what I have to do, what is the midpoint of this interval? It has length 5, so 2.5 from here, so it's 1.5. Plus, I'm applying the Gauss formulas, and then the positions are 1 divided by 3 plus minus 1 divided by 3 times half the interval length. Interval length is 5, so half of that is 2.5. So we get these numbers. Now we need electronic help to find the decimal representation of this number. Okay, we do so, and now Hans needs an electronic help to evaluate this function at these 2 positions. So these are the input values, and the function value at these positions is 0.05664 for the minus, and for the plus 2.943376, and I get this information of Hans, and then I tell him, applying the formulas, I need the interval length and half of that, so 4 minus -1 divided by 2, which is 2.5, times then first weight times first function value plus second weight, again a 1, times second function value. And then if I do that calculation, I get 124.58. If you do the job with more digits here and here, you will see also the following digits, all digits are correct. So now Hans is really surprised, really surprised, because now he knows I can't reproduce his polynomial. I know only two function values for two positions. And in this case, it's absolutely impossible to know which polynomial Hans used. So this is really, this is true magic. Now Hans is really surprised. And maybe on the way to his home, he had an idea. This is really surprising. If I am able to reproduce the integral value on basis of that information, what does that mean? That means that every polynomial of degree 3 interpolating these 2 points, x, y values, these 2 points, then every polynomial of that kind must have the integral value 124.58. Identical integral value whichever polynomial you're taking, if it's only a polynomial of the type that it interpolates these 2 points. And there are infinite many polynomials, completely different polynomials. That's really surprising. That's so surprising that it is unbelievable. So what did I do when I thought about that? I programmed in MATLAB the following. I've chosen this instead of n is 2 is n is 3. I hope that does not confuse you. If somebody has, in this case, n is 3 means degree 5. If somebody has a degree 5 polynomial, and if I have at these positions some given y values, then all these polynomials will have the same integral value. So here we have these positions. Now we take the standard interval -1, 1, and let's say I have these function values. Function value 1 at position -√3 divided by 5. Function value 3 at position 0, and function value 2 at position √3 divided by 5 positive. And then I can choose whichever polynomial I want. So what did I do? I am choosing 3 random positions on the x-axis, and then I am choosing some random y values. Then I find the polynomial interpolating all these 6 values. That means it includes these 3 positions here, the given positions, and the 3 arbitrary points on top. And then I'm using polyfit. This is the command in MATLAB in Octave. Find the polynomial interpolating for these x values, these y values, and use a polynomial of degree 5. In this case, this means true interpolation. 6 points is degree 5. And then I am plotting that, and then I show you. Let's run that code, and I'm seeing the following. If I have this blue polynomial on the interval -1, 1, I get the integral value 4.333. Okay, the area between the x-axis and the function here is 4.333. If I'm choosing this polynomial, it also interpolates these 3 points. It looks completely different, but it has in common with the first function, the dashed one. Then the integral value is also guaranteed also 4 plus a third. And whichever polynomial I am choosing, always the function value is 4.333. And that is really, really surprising to me. Here I'm calculating the integral value by applying the quad command. This is the MATLAB, the octave command to find the integral value. I am using my polynomial here. After polyfit, I have the coefficients of the polynomial, and then I can evaluate the polynomial using the command polyval. And then I'm integrating from -1 to 1, and the answer is always 4 plus a third. Always, whichever polynomial interpolates these 3 points, the integral value is always 4 plus a third. And that is really, really surprising, stunning. It's unbelievable. I am sure you cannot sleep tonight because you always have to think about that miracle. At least for me, this is the case. I am really, really astonished. I'm really, really surprised. This is unbelievable. Okay, what if Hans misunderstood here something? Maybe instead of hearing degree 3, he heard degree 4. What would have happened in that case? That's what I want to discuss now. Then maybe he would have chosen the polynomial, and maybe he would have chosen the interval. Then his integral value, antiderivative value for 2.5, value for 1, and he gets 24.441. So here he would say, okay, the integral value is 24.441, but he did not tell me. Then I would have asked him for the values at position 1, 1 minus 1 plus 2 minus 1 plus 5 is a 6, and 1.5, then he would give me position 2 is a 19 and position 3. And then I tell him interval length 1.5 times weights 1 divided by 8 times first function value 3 divided by 8 times second function value, and so on. And doing so, the result is 24.469. Then I would tell him, I know your integral value, this is 24.469. Then Hans would say, no, that's not true. It's almost true. You are very close to my solution, but it's not correct. The correct solution is 24.4, but then instead of 69, we have a 4.1. So maybe Hans is impressed, but there is something wrong. I say, no, I'm sure that this is the correct answer. He says, no, this is my value. And then maybe we are looking at what is wrong, and then I see, oh, Hans, you used the degree 4 polynomial. I told you that you have to choose a degree 3 polynomial. And then, okay, this would be the misunderstanding. Okay, maybe in that case Hans misunderstood that. maybe in that case he says, okay, I am choosing that polynomial and that interval. What would happen in that case? Midpoint of interval plus half interval length times minus 1 divided by 3 plus 1 divided by 3, and then this is 1.317 and 2.183. I ask Hans in that case, please give me your polynomial value at position 1.317 and all the digits following I'm also telling him, and then he will answer me 7.876, and the function value here for that input argument is 24.6552. And then what would I do? I would do the following calculation: half the interval length times 1, weight is 1, times that function value, plus weight 1 times second function value, and then I will give the answer 24.398. So in this case I would tell Hans, okay, your integral value is 24.398. Then Hans will say, no, that's not true. The correct value is 24.441. So you are close to the correct integral value, but it's not correct. Then I would say, no, I'm 100% sure it must be this value. And then again, doing the discussion, we will find out that, okay, I am producing values which are not correct in that case, but I'm very, very close. And this maybe is even more surprising. Hans says, okay, it's impossible to reconstruct my function out of this information. For a polynomial of degree 4, you need 5 informations. You need for 5 positions the y values, whichever positions. But if I have 5 positions and the corresponding y values, then you are able to reproduce the polynomial. But if I have only 2 informations, 2 instead of 5, then I am able to come very, very close to the correct value. And that is really, really surprising for me. It's always, every semester again, really surprising that this is really working, that this is really true. So this is kind of miracle, mathematical miracle.